Hello. Hello, Miss French. How are you? Hello. Hello. Can you hear me?
Yes. How you doing?
How are you doing?
Good.
For about 4 of you have registered in my Pearson, my Lab Plus. That's good because they have 2 assignments due this weekend on that. Please, if you have not registered, please try and register it. And also, please always check my announcement. I have an announcement that I did in Canvas for this week that tells you the assignment that are due this weekend. I have graded the first discussion where now this week I'm going to grade your first Excel assignment. Now, the assignment you do in Pearson My Lab are automatically graded as soon as you finish them. Then all I have to do, if it doesn't show up in the grade book automatically, then I have to transfer them to their grade book myself. So we go from there. So I feel very I'm happy that at least four of you have now registered in my that's my lab. Mr. Aaron, can you hear me?
Yeah, I'm here.
So you finally did it. I saw your name.
Oh yeah, I did it.
Very good.
Can somebody let me know how they do it? Because I tried. I couldn't still figure it out.
Me either.
Aaron, so
right now I just had to do the temporary thing, but so that ends on February 28th. So on February 28th, I mean, like I said, with the access code he gave us, I don't know why it doesn't work, but on the 28th, I'm just gonna have to opt out and purchase it again.
So
Oh, okay.
I don't know why that access code doesn't work because they are already built in my that icon that I told you to click to get access code. They're already built in my in the course shell. So what I actually give you is the class ID, my course ID. If you needed it, if the registration, if you ask for it in the registration process. So I don't know, and even it's the same textbook we're using. I don't know why. I don't know what to tell you. But please.
So should we opt out of it so it don't be on our what's it called, our student account?
Can you say it again?
I said, should we opt out of it so it don't show up on our student account?
That's the thing, though. I think if you opt out, you still have to pay for it again. So it's like they already took it out of our tuition.
Yeah,
and
that's
then
what I'm saying.
You end up having to pay for it again, unfortunately.
You know what I'm going to advise you to do?
Oh, wow.
Call Pearson. I will look for the number that I could give you to call their tech support. Maybe they can guide you through it. When you call them, give them the information I gave you, the course ID, and let's see what happens. Yeah.
Okay.
Yes, call them and see their tech support and see. Give them. I've already have it. I gave you the current information after I went back in India and then brought the news course ID. Either one, the first one I gave you, the second one I gave you. If you use either of them, I'm still gonna see your work after you did it. Okay. So try and do it today or tomorrow so that you can be able to finish your homework by weekend. Okay.
Okay.
All right, let's see. Today, last week, Friday, I wasn't. I have to cancel the class because of an emergency I had. But now, but prior to that, on Wednesday we stopped at. Let me share my screen with you. we finished the histogram. We finished the histogram. So we did a histogram, frequency, polygon, and cumulative frequency as a graph. That is the archive. Today we'll be looking at shape of distribution and probably the other types of data. Now we'll begin with this. You can see my screen, right?
Yes.
So some distributions have what we call humps or peaks that we call mode. So now we are going to come across mode again when we start doing a data description. Now we use this mode to describe the tallest bar or the tallest point in the distribution. We call it the mode. I mean, for now, for example, if you look at this histogram, it has only one hump. I mean, the tallest bar here, this one here, we call the mode. So we say that it is a unimodal distribution because it has only one mode, only one hump, only one tallest bar here. And I'll give you a good example of where this is applied in real life situation. When you look at the sales volume, sales volume in a restaurant, my mistake, I'm gonna make sure everybody's seeing this. What happened to me? Just give me 1 minute. So 1 minute, we're gonna continue in a few minutes. All right. I'll make sure I have everything. Yep. So the sales volume in a restaurant, we have during the lunch time, you know, the volume will be, I mean, people will be coming in. If you can see this chart, people will be coming in. And then during lunchtime, like from 12, it goes, oh, sorry, I think this is the first one here. It goes up during lunchtime. From 12:01, it goes up. Then after that, it starts to trickle down. So I give this, so you have a peak during the lunchtime. Yeah, so sales goes peak sales. Now, another example can be sales during Christmas time. It comes, it goes up, and it goes down. So now, some distribution can have 2 humps or 2 peaks. You can see this one, 2 of them, and we call them the bimodal distribution. A good example of this is sales volume in a restaurant during lunchtime and during dinner time. So those are the time we have a peak sales. And also seasonal sales during Thanksgiving time or Thanksgiving season and Christmas season. Now, next is the sales volume, a distribution that have more than 2 humps or modes. We call them bimodal distribution. Real life example. Let's say somebody is diabetic, right? So it might have blood sugar peaking, going up, and then the person takes the medication, it goes down. Then it goes up again, then goes down, up and down, you know, fluctuating in spikes. So that's to give you an example of a distribution have many peaks. Another one is the blood pressure fluctuation. If you plot the blood pressure of somebody who has blood pressure issues, keep fluctuating, you know. And also the stock price. If you look at the stock price, let me show you the stock price. I can use Yahoo Finance, finance.yahoo.com. and I can use any company. Let us look at, there's this company that was making a lot of news last 2 weeks. I think they call it Game Shop, I think they call it. Let me see if I can pull it up. Game Shop. Yep, Game Shop, GameStop, I think they call it. Corporation, that's the one right here. GME. Now, when I put the chart, let me put the chart. I put the chart, you can see that it has a lot of fluctuations, peaks, and it goes up and down. I'm gonna make it 1 month. See, you can see up, peak here, it peaked here, and it peaked here, and it continued. Let me make it. If I make it 3 months, you can see different peaks. You know, these are not histogram. It's more of is a time series. That about it is more of frequency polygon. So you can see up and down peak. Sometimes it goes too high, and so on and so forth. So for such distributions that have many modes or many humps, we call them multimodal distribution. And I have given you 3 examples here. Now, we also have what we call the uniform distribution. Now, in the uniform distribution, it has no hump, no mode. All the bars or all the heights are approximately equal, the same height. Okay. Now, look at how it looks. Uniform distribution. I think this should be respondent. I spelled it wrong here. Anyway, this is how it looks. And I'll give you an example, a real life example. Now, if somebody says, if you participate in this study, you are automatically qualified for a $50 or $25 gift card. So now, if you are the first respondent, you participated in the survey, you are given a $25 gift card. The second person was also given a $25 gift card. The third person was, so everybody that participated in that survey was given a $25 gift card. See, it will give you a uniform distribution, no peaks. Any questions so far, class?
No.
Good, very good. Now, this leads us to the skewness and symmetry. Now, there are distributions that if you plot them in a graph, it will give you what is called a symmetric appearance or a symmetric distribution. I'll give you an example. What we call it symmetric distribution because it is basically a mirror image of both sides. Let me say, I wrote here that such distributions are bell-shaped, tapers at the end, at both ends, and have a single peak here. So we call them symmetric or normal distribution. And I'll give you an example. Now, if you get the blood pressure of normal people that have normal blood pressure of everybody that have normal blood pressure in Maryland, it will give you a smooth distribution in this form. Like if you make a chart, and I start it at the middle of each of these bars and join them with a line, it will give you a smooth curve. I mean, if you do it for a small sample, it won't give you a smooth curve. It has to be a large population, the entire population of people with high blood pressure. Or if you are talking of teachers' income, the annual salary of teachers in Maryland, to plot them, it will give you, of course, some counties pay more than other counties, but if you plot all of them in a chart, it will give you a smooth curve. Like it would look like this curve here. Have a single peak and then tapers on both ends. This line here doesn't touch. See, it doesn't touch the line here. So the curve never touches it. You see that you have an asymptotic tail, and they see both sides. You can literally fold this side to that side. It's just like your body. See, Yeah, but if you can use a knife and cut it halfway, you can see that this half is the same as the other half. You know, so we call it symmetric distribution. So it usually see this when the entire population are involved. Like if you plot a graph of all the heights of adult female in Maryland to give you that, smooth curve. Now, there are not every distribution is normal. Not all of them. You know that there are some exceptions. Excuse me. Now, look at this. We call them skewed distribution. Skewed. Now, how does it occur? The distribution is said to be skewed because one tail of the distribution stretches further or farther than the other. One tail, see, this side stretched more than this side. See? So in that case, we say that because it stretched more on the right side, we say that it is skewed to the right, and we call it right skewed distribution. Now, if you plot the chart, it will look like this. This side stretched more. Now, I'll give you an example of right skewed distribution. A real life data set that involve right skewed distribution. Okay, we have there. Let's income. Income is usually right skewed. Income data. Why? Let's assume that this is income. Okay. Let me go here to this one. If this is income data, and here is let's say here is $10,000 per year. Here is $20,000 per year, and here is 100,000. So as you go all the way to where we have millionaires, you can see that you have more people with low income congregating than those that have high income. Let me put it in this way: we have much more people, much less millionaires and billionaires than people who are middle class, or less. So income data is usually skewed to the right. Another example I'll give you is this. Here, if this is blood pressure, now I think there are much more people that have normal blood pressure than those that doesn't have it, because those that usually have high blood pressure issues are the elderly, and the population. I think the younger people are more in population than the elderly. Am I right or wrong?
You're right.
Yeah. So it can be, but income is very clear that we have much more people with smaller income, middle class or less, than the millionaires and billionaires. So it is more clear. Now, I'll give you another example. Let's say that I gave a test that is very hard, right? So this is 10%. Those that will score 10% to 50% will be higher than those that will score 90% and 100%. See? So a difficult test, a challenging test, challenging exam, excuse me, exam will have, if you plot this graph of the score, it will give you a right skewed graph or histogram. Now, let's look at the less skewed. Less skewed is when it's stretched more on the left side, on the right side. One good example of this is if I give an exam that is very easy, an easy exam, you see more people scoring 90%. Let me use this one, 90%, 100%, and less people scoring 20%. See, that will give you a less skewed distribution. Now, of course, you know that we have outliers. We use them outliers for those data values that stand out from the crowd. For example, There's this neighborhood in Baltimore City that is called the North Avenue. So you have people with low income. There are more people with most people that live in North Avenue have either low income, more of low income population, then a little bit of middle class. Now, if you go to that neighborhood and see that a millionaire is living there, that millionaire will be an outlier, you know. And I'll give you another example. I have more examples. Usually you understand this concept with examples. Now, suppose I take one of you here and put you in a third grade class and give a test in addition and subtraction. You know, you're gonna score very high compared to the student in the class because you become an outlier. Your score will be an outlier. So outliers in graph, this is how we show them. See this gap here shows that this particular histogram is an outlier. It stands out. It can be either way. It can be both sides. You know, it can be on the left side, on the right side. Like here, we have a Baltimore City and our income data. So if you go to Baltimore City, you see a lot of there's some people, not a lot of, but some people who are most people live in their houses but there's still some group of people that are homeless. You know, those are outliers. They stand out, from the crowd. So that will give you an idea what an outlier is. And I can even explain more. Let's say that you see it, we know that teachers are, I would say middle class, right? But if you see a teacher who is making $1 million a year, that is an outlier because that teachers don't make millions a year. The teachers make maximum 80,000 a year. I mean, this one is even an outlier for Baltimore County, And I can give you many examples of outliers always stand out for the crowd. Questions for me? Hello, class. Any question for me?
No questions.
Good. Now, so let us look at the other types of charts. Today we'll be able to do one of them and then finish the rest by the Friday. Look at what we call the stem and leaf plots. Stem and leaf plots. Okay. So in stem and leaf plot, we actually plot the actual data values instead of using the average form, or like we did the modified form. Like when you do histogram, you get the class interval and then frequency, then you use it to plot. But in stem and leaf plot, we actually plot the actual numbers. Excuse me. So let us see how it goes. If you are given a number to do to present in using a stem and leaf plot, if you are given a data set and you are required to present them using the stem and leaf plot, the first thing you do is to plot arrange them in order first. Then you can now make your stem and leaf plot. Now, Excel 2016 doesn't really have an option for making stem and leaf plot automatically. I don't know if other versions can do it, but it doesn't have it. But one thing Excel can do is you can use it to arrange the data in order in a few minutes. Anyway, then from there you can now make your stem and leaf plot. Let's look at this example. An outpatient testing center. At an outpatient testing center, let me make this a little bit bigger so you can see it better. Good, that's better now. Okay. In an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. 25 cardiograms for this particular day. For day 2, 31 cardiograms. Now it says construct a stem and leaf plot to represent this data, then explain your results. So, like I said, the first thing you do is to put the data set in order from the smallest to the largest solution. Okay. And from there, you can now pick your numbers to make a StemLeaf plot. Now, if you look at the example here, you will notice that it started from 2. I have arranged them in order already here, excuse me, and all the way to 57. And they all have 2 digits. Because of that, you gotta make this to comply, it's 0, 2, see? So that they will all have the same digits. Now you can put your stem and then the leaf. The stem represents the let me put it this way. Yeah, the first digit, the last digit is always the leaf, and the main digit after that is the stem. Let me show you what I mean by that. So here, let's look at this 2. 0, 2. Okay, 2, which means that here the stem is the 0. It becomes the stem. Okay, a mistake. What I put 2 arrows. This is your stem. Oh, excuse me, a mistake. This is your stem right here, and this is your leaf. So the stem is the stem, and your leaf is right here. Leaf. Yeah. Now suppose we are using this number 32, or let's say 51. Okay, 51. We got 51. The last one is your leaf, and the first one is your stem. So always have in mind that the last digit, which is one digit, is your leaf, and the other digit after that or before that is your stem. So here we have the stem as, okay, 5 is the stem, excuse me. This is the stem, and this is your leaf. Leaf is the 1. Okay. So the last number, if they have, let's say that we have 3 numbers. Let's say that we have this thing where we have 243 or 245. This last number here becomes your stem. When the first 2 becomes your, sorry, this number here becomes your leaf. The first 2 becomes your stem. So the last digit is always your leaf. Okay. So you have that in mind. So with this, we are ready to construct our stem here, and then our leaf. Okay. And then arrange it properly. Now, okay, now here we started with first. So from 0, 2 to 57. If you look at only the stem, you can see that we have 0, 1, 1, 2, 2, 2. See, if you're looking only at the stem, 3, 3. So that means it started from 0 to 5. So we got 0, 1, 2, 3, 4, 5. So we have only one that have 0, 2. So 0, 0, 2. See? So that means 2. Here we have 13. You already have 1 here. So for the 13, you're gonna put only 3. See? 3. And for 14, you're gonna put only 4. That'll give you 1 and 4, give you 14. Now that's end that one. Then for 20, you already have 2 here. So all you have to put here is the 0. That gives you 20. And you got 23. So you have 2 here already as the stem. So all you have to put is the 3. So you follow that process. You're gonna go put 5. I think that's it for the 20, 22, 25. Okay, now we have okay, let me see. 31. You got 3 here already. So all you need to put is 1. I'll give you 31. Then you have 32. 2, 32. Then you got another 32. 2, and then another one, which is 32. Then you got 33. 36. For the 3, that we're gonna start with 4. So in that case, you have excuse me, a mistake. For 4, we got 43. You already have 4 here, so you're gonna put only 3. That'll give you 43. 44, 4. Another 44, 4. Another just 45 this time. 45. Then for 51, we got 5 here already. So that we have 51, 52, and then 57. And here, that's your StemLeaf plot right there. So I'm gonna make sure the stem is centered properly. See? So if you look at these charts, if you turn it counterclockwise, you discover that it is it looks like a almost approximately symmetric, right? Am I right? Am I right or wrong?
Yes, you're right.
If you turn it counterclockwise, it looks almost approximately symmetric. So you can say that interpretation of this the data set is approximately symmetrical. Now, this is this is one way of interpreting it. There's other ways you can interpret it. I'll explain. Let me make this bigger first. Okay. Yep. So now, as this is an outpatient testing center, you can also make sure I have everything down properly. Yep. Now, okay, you can see on that on this is how many days? 20 days. You can say that on between 7 out of the 20 days, we have number of patients receiving cardiogram we have 31 to 36 patients. Say 31 to 36 patients. Now, in this case, you have on 7 out of the 20 days. So how many? So 1, 2, 3, 4, 5, 6, 7. If you want to do it that way, or I can say that maximum during that same period, approximately between 2 to 57 patients, we are giving cardiogram, or you can say the maximum number of patients that receive. The number of patients that the number of days that they got more, or the maximum number of patients that received the cardiogram. You can say the 57 patients on a particular day. We have 57 patients. See, this is 55 and 7. You can also say that at a minimum, we have 2 patients receiving cardiogram, and also we have 57 patients, between 2 to 57 patients. Now, you can equally say that this data set have a peak, one peak. So the largest amount of patients that receive cardiogram on any particular day is 36 patients. One particular day. Sorry, you can say that on one particular day, there is 36 patients that were given cardiogram, but the maximum that were given in a particular day is 57 patients. So there's many ways you can write the interpretation. But for you, what I'm looking for is tell me whether it is symmetrical or not, or whether it is skewed or not. That's exactly what I need. Then, journalists can write more on this. They can even write an article of volumes based on this same small data. But we are not journalists. We are statisticians. We go straight to the point. So just tell me that if the data set has a mode, has one mode, say 36 is one mode, that is the maximum, 10, or whether it is symmetric or not, whether it has outlier. I'll give you, let's try this example here. It says, the Cornell Lab of Ornithology, let me make it a little bit bigger. Okay. So the Cornell Lab of Ornithology hold annual Christmas bird counts, in which bird watchers at various locations around the country, see how many different species of birds they can spot. Here are some of the counts reported from Texas during the 1999 event. That's the various counts. Create a StemLeaf Plots to present this data and then interpret your result. Now, or it's write a brief description of the distribution. Okay, I'm gonna put this in here. Solution. Actually, the solution should be here because I've already arranged them in order. So I'm gonna right here. Okay. Now, for this solution, first thing is to put them in order, and I have see the smallest is 152. Oh, did I move it? Okay. I'll put them back here because I make it bigger, so it shifted. Anyway, so I have arranged them in order from the smallest to largest. Then now we can put our StemLeaf. Now for this one, I have the first number is 152. 152. 5, 2. So remember, like I told you, the leaf is always the last digit. So in this case, your leaf is 2. And your stem is 57. I'm gonna do it this way. Let's see this thing can turn. Okay, stretch it a little bit. And then turn it around. You can turn it around. Let me turn this around. Okay, I'm gonna just 1 minute. I'll fix it. Let me shift this. Okay, make it at the center. Center 152. 2. And I have this. Okay. This is your stem. I'm not getting it, but I'll get it. Just give me a few minutes. It's just a minor. Okay, from here. It's not showing. Okay, let me use a simple way to make it simple for us. This is your stem. Look at it showing now. This okay, this one is showing. I'm gonna remove this. This is what I was trying to do. Now I can move it around. It wouldn't move. So let me just delete it. Now, this is your stem here. And then I'm gonna insert this. This is a stem, the highlighted one. See the first two numbers. Always bear in mind that the last digit is your leaf. So that means it doesn't matter how many numbers on the left side. As long as you know that the last digit is your leaf, you should be good. So your stem is 15. Stem. The leaf is the last digit, which is 2. So in that, if you follow the same process, a number like 177 will have a leaf of 7 and a stem of 17. Okay, now with this, we are ready to plot our graph. I got I put insert this here, stem, leaf. From here, we can see that the first number is 15. If you look at the stem only, you have 15, 15, 15, 15, 15, then 16, 16, and so on and so forth. So it started from 15 and ended is 22. If you look at this, only the stems. So 15 to 22, you got 15, 20, 16, 17, 18, 19, 20, 21, 22. Now, okay, let's arrange this. The first number we have is 152, followed by 153 twice. So 152, you already have 15 here, so you put only 2. Next one will be 153. So you already have 15, which is 3. So following the same process, I got 153 again. And I got 156. 156. Then the 157. Now, next is 160. See, 160 twice. So you got 160, 160. You got 163. Sorry, 162. You get it twice. So you have 162, 162. Next is 163, 163. Next is 166, 166. 167, 167. That's ended 160. So next thing we have 175. Okay. 170. So you got 17 already here. So 175. 177 and 178. So you have 177, 178, and that's it. They have 181 and 183. So you got 181, 183, 186, 186. Then we have 206. So we don't have 190, but we still gotta put it there so that it will be, have a common difference here of 1. So, but we don't have 190, so we gotta skip it. So what we have is 206, 206, because we have 20 here already. Another 206. Now I have 228. We don't have 21, so we have 228. So we have 22 here already. So 228. Now look at our StemLeaf Plot right there. Now, if you turn this thing counterclockwise, you will see that it is skewed. See, skewed to the right. Am I right?
Yeah.
Also, it has gap here, 2 gaps. So which means that there's 2 outliers. So interpretation the data set is skewed to the right and it has 2 outliers, 2 that are standing out, outliers. Questions?
So like for the number like 1,000, would you like split it in half, or would you put 100 as your stem and 0 as your leaf?
Yeah, 1,000 will be 1,000. The last digit is your leaf. So this is becomes your stem right there. 100 is your stem. Your leaf is 0.
Okay.
So the key word is this. Just have it in your mind that the last digit is your stem. Then any digit before that is your leaf. Sorry, that the last digit is your leaf. Then any digit before that is your stem.
Okay. Yeah. Thank you.
Welcome. So any other question before we round up?
I do have a question, but it's not about the session. It's about one of my class assignments.
Yeah,
the class discussion. It's about my grade. I'm just confused why I was given a 0.5 out of 5, even though I thought I followed all of what was asked of the question.
No, you're not giving 0.5 out of 5. Maybe
yeah,
maybe you submitted it after I've graded it. Is that?
I've submitted it right on time.
Writing them down. It can be if you submit it on time, you can't have 0.5. So it says 0.5 out of what again?
0.5 out of 5.
No, it probably an error. I will check it after the class, okay?
Okay, thank you.
You're welcome. If you have submitted it on time, you have their full point.
Oh yeah, I just checked too. I got like 0.2.
0.2?
Mm-hmm.
So what's your name?
Jada Bennett.
Jada Bennett. Jada, are you sure?
Yes. I just checked too because he just said something.
Yeah, it says I have a 5% in the class, so that's why
it has 5% of the class. Yes.
I have a 5% too.
You have 5%?
Yeah, I got like a 2.5. I mean 0.25 out of 5.
There gotta be some problem there. So it's 5% of the grade. So if you submitted it and followed all the instructions there, you should be careful. Let me show you my screen. Okay. Let me show you my screen. Let me see what is showing on my screen. So probably, I don't know why yours is showing differently, but I will show you my screen now. Share this. Okay. Morgan. Everybody that submitted it. Okay. Okay. Good. Let me show you can see the screen, right?
Yes.
Okay, Mr. Jeda, see. Can you see here? Can you see here?
Yes.
So, Mr. Taylor, right? Taylor.
Yes.
See, you have your 5% right here. So maybe you're looking at the weighted grade. Let me see. Maybe see even the total here. Can you see the total?
Yes.
Yep.
It's still showing 5%. You already have okay, Miss Jeda. You see how you have your 5% right there. So when did you check your grade book last?
Just now.
Yesterday, or actually this morning.
So what is it showing now?
So it's saying like 0.25 out of 5 points.
Yeah, we should have gotten a 5 out of 5.
Right. So instead of saying like 100% is telling us just 5% out of 100%.
Mhm.
It's 5% out of 100% because the discussion is only hold on, let me show you something. Let me show you one more thing. I think it's
So is it that the discussion is 5% of the grade?
yes.
Okay, so I understand
Okay.
that, but shouldn't we still have a 5 out of 5 for the discussion because we completed it correctly?
Yeah,
Right.
it shows 5 out of 5 on your end, right?
No, it doesn't show 5 out of 5 on our end. That's the problem.
It's
It
showing
shows
0.2.
right.
0.5.
It says 0.25 out of 5 instead of saying 5 out of 5, even though the discussion is 5% of our grade.
Right.
I don't know, this technology sometimes they add to weird, but you can see from the screen here. You can see from the screen here. I was looking into it and see why it's doing that.
Okay.
But right here, you can see that Nick Taylor is 5%. You get your 5%. Jada, you get your 5%. Everybody got their 5%. Everybody that did got their 5%.
Okay.
Okay.
Yeah. So, but I'm still going to look into it to see why it's showing that on your end. Okay. Any other question for me?
No.
All right.
Have a good night.
You too. I see you on Wednesday.
Thank
All right.
you.
Thank you.